A trace is a way for you to reach out into your level and get feedback about what lives there so that you can respond appropriately. Today I'm going to show you how to set up a basic line trace so you can use them in your project. To begin, you're just going to need a character that you can control, an object in the world that we're going to trace against, and a level, just so that our character doesn't fall into the void. I'm going to be using the third-person default project in Unreal Engine, and this is going to be a C++ tutorial, so we're using the C++ project. To get started, go into the content browser, and we're going to go into our C++ classes, open up the project that contains our files, and open up our third-person project character, or the character file for whatever project you're working on. Once that opens, you're going to have access to both the C++ file and a header file. We want to go into our tick function, but the tick function does not exist by default. So we're going to go into our header file, and we're going to scroll down to the protected section. To set up a tick on a character, you're just going to type virtual void tick, and we need to pass in a parameter that is a float called delta seconds. If this is not set up exactly like this, then it's not going to recognize that it's the right tick function. That includes the parameter name here. Just make sure it's delta seconds. Now we can go ahead and create a definition in the third-person C++, and the last thing we do is call to the super method or the parent class, where we call super tick, and we pass in that delta seconds variable, and now we have a tick function that's going to run every single frame. Disclaimer, I don't usually recommend running a trace on tick because that's going to be very expensive, but for the purposes of this tutorial and teaching you how it works, it's going to be just fine. Now, here's the code that's going to run our trace. Specifically, this line here is what actually does the looking. Let's take a look at it. Hovering over the method, we can see that this is going to return a Boolean. That means that we're going to get a true or a false value depending on if this line trace finds something that it hits. If we do get a hit, then we're going to populate this first variable here called the hit result or the out hit with the data of the object that is hit. That little ampersand, along with that little out hit or the out prefix, means that we are going to get data back after this runs. So that means we need to have a variable ready to receive this data, which is why we have this line here. This hit result is going to be populated with the result of the trace if we hit something. Trace start and trace end are both vectors that represent the space that we are going to be tracing. So since we're drawing a line, we have to represent both sides of the line, go figure. This represents the type of object that we're going to be tracing for. Let's dive deeper into this so I can show you. If I click on any object in the world, if I go into their collision presets, we can see right now that the collision preset is set to a physics actor. But if we expand upon this, we can see the responses that are going to be triggered for each type of channel. And we can see here that this object is going to block every single collision channel. This means that it's always going to trigger on a trace. But in our code, we can specify either world static, world dynamic, pawn, etc., depending on what we want to be looking for. And each of those corresponds to a trace channel that happens right here. So for instance, for this tutorial, we're going to be looking for world static objects because I just want to hit everything. And this params variable is something we're going to come back to in a bit, but basically it can be used to set extra parameters for what we want to catch or not catch within our trace. So now that we understand the theory, we're going to get started doing it now. First, you need to subscribe to this channel so you can keep learning Unreal Engine with me, and then we're going to fill in the values for our trace vectors. Since this is a third-person project, I want to do this by using the direction that our player is facing. GetPlayerViewpoint is a very handy piece of code that is going to give you the direction that your camera is facing. This is a very strong function for third-person projects because it's going to give you the location and the rotation of the camera that you can then use. If we hover over this, we can see that both the location and the rotation are considered out parameters, which is why we have to create these two f-vector and f-rotator variables to catch that data. So now that we're going to be able to have our player's viewpoint, we're going to use the trace start, and we're going to make that equal to the location of our player's viewpoint. And then our trace end is going to be a little more complicated. We just basically want to draw a straight line, but we need to do so in the direction that the player is facing. To do that, we can take the rotation variable that we just got, and we can call a method off of that called vector. And that's going to convert that into a vector that we can use for math. And then from there, we need to multiply by some sort of range variable that I'm just going to set to 1,000 for today. But this dictates the length in the direction that we want to trace. And now we're going to set up this mysterious params variable. This is a type fCollisionQuery params. And what this fCollisionQuery params does is it lets us do very interesting things. Since we're in the third person and we're going to be doing our line trace from our camera, we should be intersecting with our player. If we don't ignore our player, then we're always going to return that we're hitting our player because they are always going to be in the way of our trace. So to do that, we can take our params variable here and we can hit add ignored actor and ignore this actor. That way, when the trace happens, if we do happen to intersect with ourselves, which we will, then we'll ignore that and only look for the next one. So now the trace is actually ready to run, but in order to do anything based off of the results of the trace, we need to leverage an if statement. Remember, this line trace single by channel is a Boolean method. It is going to return true or false. So we can actually use this as our if statement criteria. So if our line trace hits something, Our hit result variable, which we did declare up here, will have data in it, and we will go inside and use whatever's in this if statement. Now, I don't want to do anything too complicated, so I'm just going to do a UE log. And I'm just going to say that if we hit something with our line trace, then I'm going to log to the console that we hit something. Now I'm going to save everything that we've done and I'm going to compile. And I'm going to go into my output log here and I'm going to hit play. So now you can see when I'm looking up into the sky, my camera isn't hitting anything within range, so nothing happens. When I slowly pan over this way, we can see as I'd start becoming to intersect with a player, we start seeing that we're hitting something and our log is displaying. But that was not very informative. We can actually make it so that we can throw out a line that shows us where our line trace is going. To do that, let's go back into code. So right before we would use our if statement to actually do the trace, we are going to use another function here. And the code here is this draw debug line. Where the line trace has collision data, draw debug line does not. It just exists in the world for debugging purposes. And that's why it's going to use a lot of the same parameters. Specifically, we're going to use the world that we need to draw in, the start location of our trace, the end location of our trace, the color that we want to be displayed by the line, and then this is a Boolean that dictates if we want the line to be permanent or not. I don't usually recommend that, the screen can get busy very fast, so set it to false and then give it a how long do you want it to live in the world variable. So that means every single frame we are going to be doing a line trace, but we're also going to be drawing a line that is going to last for 2 seconds over the same area. Let's compile this, and now when I hit play, you'll see nothing specifically looks different. You can see from our dummy character that there is a giant line shooting out of their head, but as I rotate, you're gonna see that we're shooting from the camera. Again, this was the whole point. We're in third person. We're shooting from our character's camera point of view. And this is why we had to have that params variable set up. Otherwise, we'd always be colliding with our actual player. And you can see as we look around when our log message should be displaying, and we can always adjust our distance or anything about where we're actually tracing if we wanted to. But that's the basic concept. Go out there and use tracing to meet your nefarious ends. Subscribe to this channel for more Unreal Engine stuff, and I'll see you next time. Have a good day.